To get the free notes of electrical circuit, check the link in the comment section and install the app for free. Mesh analysis. Question. Determine the currents in each branch for the network given in figure. Here in this circuit, we have to determine its branch current by using mesh analysis. Solution. First of all, let's say this is mesh number 1 with current I1. This is mesh number 2 with current I2. And this is mesh number 3 with current I3. All the currents are in clockwise direction. Now here we can clearly see I1 is equal to 5 ampere. I1 is equal to 5 ampere because here this is a current source. Now here we can see this I2. So to find this I2, let's apply KVL. Apply KVL. KVL stands for Kirchhoff's voltage law at mesh number 2. Apply KVL at mesh number 2. According to the direction of this current I2, this will be positive here. And here this will be negative. Positive here, negative. This will be positive and this will be negative. Now, let's say we are starting from this point. So it will be plus 10 I2. So plus 10 I2. Then plus. Now here this is common in this mesh number 2 and mesh number 1. So it will be like this. 10 I2 minus I1. So 10 I2 minus I1. Then plus 3 I2. So plus 3 I2. Then plus again this 5 ohm is in common in mesh number 2 and mesh number 3. So and we are solving for mesh number 2. So it will be 5 plus 5 I2 minus I3. I2 minus I3 then is equal to, here the loop is completed, so is equal to 0. Now let's simplify this. So it will be 10 I2 minus 10 I1 plus 3 I2 plus 5 I2 minus 5 I3 is equal to 0. Now first we will write I1 terms. So here this is minus 10 I1. And now here this will be 10 plus 3. 10 plus 3 is 13. 13 plus 5, 18. So it will be plus 18 I2. Then here this will be minus 5 I3 is equal to 0. Now let's say this is equation number 1. Now next we will apply KVL to mesh number 3. So let's apply KVL to mesh number 3. Now according to the direction of this current I3, this will be positive here, negative here, positive, negative. Let's say we are starting from this point, so it will be plus 5, plus 5. Again this 5 ohm is in common in mesh number 3 and mesh number 2, and we are solving for mesh number 3. So it will be 5 in bracket I3 minus I2. I3 minus I2. Then plus 1 I3. Plus 1 I3. Then plus 10 is equal to 0. Plus 10 is equal to 0. Now let's simplify this. So it will be 5 I3 minus 5 I2 plus I3 then is equal to, if we take this on right side, so it will be minus 10. Now again first we will write I2 terms, and here the I1 terms is 0. So here we can write 0 I1 and then minus 5 I2. Then this will be 5 plus 1 6. So plus 6 I3 is equal to minus 10. Now let's say this is equation number 2. So we got equation number 1 and equation number 2. So let's solve this. Here we can see the value of I1 is 5 ampere. So here we can substitute the value of I1. So again let's copy this. and substitute the value of I1 here. The value of I1 is 5 ampere. So this will be minus 10 multiplied by 5 plus 18 I2. Here we can write but I1 is equal to 5 ampere and all the other things as it is. 5 I3 is equal to 0. So this will be 50 minus 50. If you take this on right side, so it will be plus 50. So it will be 18 I2 minus 5 I3 is equal to 50. Now let's say this is equation A, and from this equation number 2 we can skip this I1 here, because here in this equation also the I1 is absent. So it will be minus 5 I2 minus 5 I2, then plus 6 I3 plus 6 I3, then is equal to minus 10, is equal to minus 10. Let's say this is equation number B. Now we got two equations, equation A and equation B, and two unknowns. So solving equation A and B, equation A and equation B, we get, if we solve this, we get the value of I2 is equal to and I3 is equal to. So let's solve this in calculator. So mod, then 5, then there are two unknowns. So equation number 1, it will be 18, then minus 5, then 50, then here this will be minus 5, then 6, then minus 10. So it will be 3.01 ampere. Then I3 is equal to 0.84 ampere is the value of I3. Now next we got the value of I1, I2 and I3. The value of I1 is 5 ampere. So again, what we have to find in this question, determine the currents in each branch for the network given in figure. So we have to determine each branch current. That means again we have to determine further currents. So here we can see, let's say this is current I1, this is current I2, or let's say this is current IA, and this is current IB, this is current IC, this is current ID, and this is current IE. So here IA is equal to 5 ampere directly, then IB. So IB is equal to, the direction of this current we are assuming downward, so it will be I1 minus I2. So I1 minus I2. So the value of I1 is 5 ampere minus the value of I2, it is 3.01, or directly 3 only, so it will be 2 ampere. Then IC, so IC is equal to, this current will be same, that is I2, so IC is equal to I2, and I2 is equal to 3 ampere, 3.01 ampere. Then next is ID, so ID is equal to I2 minus I3, I2 minus I3, the value of I2 3.01, or directly 3 only we write, 3 minus I3 value is 0.84, 0.84 ampere. So it will be 3 minus 0.84, 0.84. So it is 2.16. 2.16 ampere is the value of ID. Then IE. So next is IE is equal to directly we can write I3. So it is I3 and it is 0.84 ampere. So directly we can write 0.84 ampere is the value of I3 or IE. So this is how we can find branch current by using mesh analysis. Check the link in the comment section and install the app for free. Thanks for watching.